What is up, team? During class today, we discussed the review for the skills quiz number 1, looking at just probability and what we've learned so far. This looks very messy, the screen. This is all stuff that we talked about in class. But we started off with some key vocab, looking at an event. What is an event? And we, as a class, determined that it's like a situation that occurs. It's just a certain way that something happens, or a piece of the problem that we want to look at. Probability is the likeliness of that event or any event from happening. It's often represented by a decimal or fraction or a percentage value. It is a numerical value when we go to answer for probability. You can then talk about that probability and then use it in a complete sentence. The probability of blank is blank. And then we have 3 different rules that we looked at. Okay. The first one is called the complement rule, and it was represented by the probability of an event not happening. So if we have, for example, the probability of event A, which we'll talk about this notation in just a second, is 0.7, then the probability of not A, represented like this, would be just the remaining value here. So we said out of 100%, out of 1.00, or out of like 1 over 1 if you have a fraction, it's whatever's the rest. And so here it'd be 0.3 representing the remainder of the 1.00. That would be the complement of event A. The additive and product rule is where a lot of students started to get a little bit confused about whether or not to apply them. The biggest difference between the two is going to be whether or not something is exclusive or something is independent. Now, looking at the additive rule for exclusive events is essentially what it boils down to. And this exclusive is 2 events that cannot happen at the same time, that cannot exist together. Now, this idea of exclusive is something that confused a lot of students because I gave this definition of 2 events that cannot exist together the very first time. It's really a rule that we use to look at 2 things, either or, happening. So when 2 things occur, but you can't have both, is another way you can think of it. 2 events happen, or are possible, but not at the same time. Okay, so 2 events can happen, but not at the same time. Okay, so in other words, it's either or for these events occurring. So this or is the giveaway that we're using in additive rule, right? So for example, if I want a gift card, I want a gift card to Target or Amazon. Maybe I can't get both gift cards because they're exclusive. They're exclusive events. If I have $50 to get a gift card and I want one to Amazon or I want one to Target, I would get one or the other, but I cannot get both. Those are exclusive events. Okay. The product rule, on the other hand, is a little bit different. Here, the product rule is used for independent events. And I added this word independent to help us think about this because with an independent events, these are 2 or more, 2 plus events that don't affect each other. In other words, they can happen at the same time. Or not. I mean, you can either they can happen at the same time, but that doesn't mean you need both of them to actually happen at the same time. So for example, here the product rule, if I wanted to draw a heart and an odd number, I could have the 8 of hearts as a card. Having an 8 Oh, I'm sorry. I wish 8 was an odd number. Let's say it's the 9 of hearts. So here, 9 is an odd number, so the event would be an odd number. And then here, another event, so this could be like event A, for instance. And then the other event could be a heart. So these two events can happen at the exact same time. Now, for example, if I were to go back to the previous, the additive rule, and I were to look at this, could I have a 9 of a heart spade? So yes, I can have a 9. This would be event A, which could be our odd number. But then the second event here, event B, you can call it a heart. But then you have another event, C, which is a spade. Now, these two cannot happen at the same time. These are exclusive events. Because I can't have a heart and a spade at the same time, I can have a 9, yes, but this would have to be either a 9 of hearts or a 9 of spades. I can't have this be a 9 of hearts and a 9 of spades. These two are mutually exclusive. Because I can't have both of them at the same time, I can't ever have that second situation from happening. Okay, so let's transition a little bit. Let's look at some notation here. So the first piece of our notes, we looked at vocab. The second piece of our notes is we're going to be looking at notation. And let's start with using our vocab again. So in event, we're going to be using a variable. In other words, an identifier. Not necessarily as a variable in the traditional sense, but just so that way we can see what an event actually looks like. So we would call this like event A, for example, is like our notation. Okay, pretty simple. Now, probability, we're then going to use, for probability, we're going to use this a P to represent probability. So we're going to use P to represent probability. And then we're going to combine that with an event so that way we can look at the probability of an event. So here we have the phrase, the probability of event A is 70%. The notation for this is the probability of event A equals 70%. So this is how I'd want you to represent kind of like the problem. And up here, the event A would just be represented by an A. And so here it would be kind of like your notation for probability usage. Now, whatever's inside of this set of parentheses can change, right? If I wanted to look at the probability of something else, for example, A and B, or A and C, or A or B, or A or C, then you can change it up. Okay, so we'll talk about that when we get to the rules. And the first one we're going to be talking about is the complement rule. And like we said before, this is the rest, right? So we use a C to represent the complement, and we treat this as a superscript. In other words, kind of like where you would put the exponent of a value. And so here we would look at this same probability A. So we'll say the complement of event A is 30%. So it's whatever the rest of the percentage is. So here if event A is 70%, the complement of event A would be 30%. So we'd have the probability of the complement of A. So you'd write it up here, complement of A. is going to equal 30%. And that would represent your notation using the complement rule. Okay. In other words, you can also look at this and you can say the probability of not A. So the rest. That could also be, you can use either of those interchangeably. Okay. Next, we follow up with the additive rule. And there's going to be a new notation that I'm going to show you today, just to make it a little bit simpler. And we're going to be using a U to represent the word or in the additive rule. The U here refers to like the union of, and we'll talk about that later on. It's not a really big deal yet. However, you may see this eventually. The union or for the additive rule. So here we're going to look and we're going to say the probability of A or B is 45%. And here we would write that as the probability of A or B, which we can write as the probability of A union, and it's like kind of like a big U, union B is going to equal 45%. Okay, the probability of A or B is going to be 45%. Now that's just the mathematical representation of looking at the additive rule. So you can feel free to use that, or you can do what I do. I still use or now to this day. That could still be okay for you. Okay. Next up is going to be the product rule. And here it's a little bit similar, except it's not a union anymore. It's N, or a big upside down U, to represent the word and in the product rule. Okay, here this N, or this upside down U, represents the intersection. It's where the probabilities overlap. And so here you would have the probability of A and B is, let's say these are two different ones, and we have 60%. Okay, you could write that as the probability of A and B, or you can write it using the mathematical notation A and B is 60%. You can do either of those pieces of notation. Okay. Now, as we move forward here and we look at this, you can have a combination of any of these things that are happening. And so let's look at like an example of a phrase. So example, this is a notation example. If I wanted the probability of A and not B, okay, I wanted everything of A and not B, then this could be represented as P for probability of A and not B, which means I want B, but everything but B. So I'd write the complement of it. Okay, now you may be saying to yourself, Hernandez, this makes no sense. What can I do? Well, here's the next piece of the notes that I wanted us to talk about for a second is kind of like how to organize your information. So I'm going to call it number 3, how to organize your info. Okay. Always start with what you have. Okay. So here we know that the probability is represented by a P. We know when we start talking about of, you have a set of parentheses, an a, and. So already you're almost halfway there. You have most of this stuff put together. It's just like this not be piece, or you can write the complement of be, right? And start going from left to right, just like you're reading a sentence, and you can be able to put stuff together. Okay, now it becomes a little bit different when you start using numbers and values. So when we start doing that, how do you organize your info? Start with what you have. Okay, whatever that value is, right? Whether this is looking at the number of cards, marbles, money, whatever like your total number is, this is going to be ultimately the denominator of your fraction if you're choosing to make a fraction. That's a little redundant. Denominator of a fraction. Denominator is the bottom of a fraction. So the bottom of the fraction of a fraction is essentially what I said here, right? And then you can start looking to find the probability of something by taking whatever it is you're interested in. Take what you're interested in, right? And then see if it has a value. So if it's worth 1 or 2, see how many of that exist within your total, which is up here. And then take that number, and this will be your numerator of the fraction or whatever you're working with. Okay, so we'll talk about this in just a second. But those are going to be like the first two pieces that we're going to be talking about. Once you find this fraction, what essentially you found is the probability. Oops. Yep, I want the red pen. Probability of an event. Okay, this is what you're interested in, is the actual event. Okay, and you just created that. We'll go through an example in the next video. You'll see the example for it. Okay, but take what you're interested, put that in the numerator, and then you're good to go. Now, what I like to do is I like to convert the fraction into what I feel comfortable with, into a decimal or a percentage. This is optional. Oops, optional. Based off of what you're comfortable with. So you don't need to do this, but it becomes important so that way you're comfortable with the numbers that you're doing in order for you to find the solution that works for you. Okay, so convert the fraction into a decimal or percentage is optional. Okay. Now, this is part of the organizing of the information. Now you need to get to the point where you're ready to start answering some questions. Okay, so once you have that figured out, repeat this process and find the probability of all the other events that are presented. Okay. Then you're going to transition into actually solving some problems. So let's talk about that in just a second. Actually, once you start doing all of this, then you're ready to start answering some questions. So check me out in the next video to start looking at how you can answer some of these questions and how you can best find the probabilities of events.